Hi, my name's Alex. I'm the developer of Star System Explorer. It used to be called Star System Generator, but now there's spaceships in it able to fly around. I swapped out its name to be a little more descriptive. This is a hobby project. I'm not being paid for this, and I'm going to give it out free and keep it free forever. Um, I've written it because there's been this huge renaissance in astronomy with the new telescopes, and there's a great YouTube community out there that explains all this stuff to you. And I was just interested in learning about it and hopefully helping others learn about it a bit more. It was primarily designed to help with tabletop role playing games like Mothership, Traveller, things like that. The sort of game where you're trundling around in a spaceship, perhaps a space trucker, and actually keeping an eye on your fuel and the dynamics of space travel. You're wanting to keep realistic yet game friendly. So bear that in mind as we go through this. This isn't meant to be a 100% accurate simulation. It's meant to be close enough to reality that actually you can relate to it. All the physics and all the maths under the hood is authentic. Nothing's really been made up. These are Kepler's equations and Rocket's equations and all of those things. They all work. And they all work quite nicely in your browser. I think writers and other people who are like generating worlds have dipped in and played with this program a bit. It's also a bit of an experiment for me as to what I can do with vibe coding and see if I can actually vibe code a universe. And the answer is yes. So, what we have here is a tool, but you just dip in, and it's getting a bit complicated. It's getting some arms and legs, so I thought I'd just put together a little unprofessional video just to introduce you to the key concepts, and you can understand how it all fits together and work. So, it has a GitHub site. You can download, install it. There's a useful getting started guide on here that can get you going. I'll put all the links in the description. But the purpose of this means you can install it at home and run it at home. But also off here, you can click on this link, which will take you to here, and it'll take you to the actual app, which is hosted on Vercel.app. You can use it for free. A little word on security. There's no need for accounts for this. It's all running entirely within your browser. I cannot see anything you create in this, and nobody can see anything you create in this because it's all within your web browser. So bear that in mind. If you go to another PC, you're not going to see your star systems, but there's plenty of opportunity to download the star systems you generate and put them on and upload them to other PCs to allow you to do that. So download every now and again. When you first start it, you'll be presented with this page. This is what you'll see when you first get in here. What is a little description, and then you can either load an example star map, which is the local neighborhood of star systems, or you can upload your own star map if you've got one already, or you can create one from scratch. So let me create one from scratch, and we can come and look at these a bit later on and use them as an example. So, you name it. I'll just keep it my star map. Don't forget, no one else sees this. There's no accounts to log in. There's no passwords. There's no security at all for you to do. Depending on your game, this here is for future expansion. But this distance units here, this is for your game world. Are you using jump routes, which are kind of jump 1, jump 2, jump 3? Or are you using it in light years, that's 50 light years or 5 parsecs or something like that? So I'll just keep it at light years. I'll just keep the defaults and hit create. And what happens is I get now dumped into a star map. This map goes on forever. There's no limit to it. You can always hit reset view, and reset view will bring everything back into view for yourself. There's the You can share the background, things like that. So poke around all you like here. And what it does is it's created a star by default. To create other stars, I can click on here and just say add a system. And what it'll do is this will keep adding systems. So this here, you'll see I've got a hex on here. This is the traveler style, and it's a snap grid. So even if I create it at the edge, it'll create it in the middle. And you'll see these are different colored stars being created, and I can create them anywhere. If I don't want to use a grid, I can just then be a bit more arbitrary in my placement. So these orangey stars, they're probably standard red dwarfs, the most common stars in the galaxy. These white ones are probably a bit similar to Earth. This will be a typo probably. But what we're doing here is effectively creating our star map. In these clicks, every time I create this, there's an entire solar system being created behind the scenes here, with a default scientific-looking name. There's a binary system just cropped up. You'll find that what this is created using the current astronomical data. So most stars are red dwarfs, and that's what you're seeing here. There's quite a few binary systems, so this looks like an interesting binary system, etc., etc. So each of these is a system. I'll show you that by clicking on it. We'll click in, and that takes us to the star system that was created here. This is kind of an interesting one. What we have here is a gigantic world, it looks like, created out here with dozens of gas giants around it. This is unlikely, I would say. But it shows you how you can quickly edit this. If I just wanted to get rid of this monstrous, crazy mess of satellites, it's very rare a planet have this many. I can actually just go into this planet and delete it. And it'll delete everything underneath it too. Oh, yes. There we go, and now we're back to a nice simple system. So you can delete and edit anything. I'll go into the editing functions a bit more. But you can get back to the star map by pressing star map. I can then go and look at another system, perhaps this one. This one looks a bit more standard. And you can zoom in, look around, take a look at here. There are 14 terrestrial planets on here. Here you can only see 6. The rest are likely to be moons. We've got some rings. This thing at the top here is your navigation. So it says there's 1 star in the system. And if you click on that, it'll zoom into that. There are 5 planets in the system, so we can see most of them. There's a big old gas giant here, so we'll zoom into there, and got a couple of moons. There's 10 additional moons, so you can see which planets they're around. Belts, we've got something with rings, so we can click here and have a look at that. Indeed, it's created another, probably a very large terrestrial planet with a moon. On the right-hand side here, it's seeing the ring. I can click on any of these and it'll bring up the properties for this here. This is a massive planet at almost 3,000 Earth masses here. So this is a huge planet, which is why it has such a big ring system and so many other planets around it. It's in fact a sub-brown dwarf with a ring, as it said here. So this is getting dangerously close to a Jupiter-like, and this is a Jupiter-like planet here. And if we, and so you can zoom around, and I can hit zoom out, and it'll always go to the next one in the hierarchy, and then zoom out again. You can use your mouse. Here's a typo star. These tend to be much quieter systems with less stars in, because each of these is generated based on the likely distribution of stars in these sorts of systems from a basic rule pack, which you can dig into if you ever want to. So effectively, what we have here is, you saw in about 20 seconds, I created dozens of star systems, some of them here, with this sort of, here's one with a binary star, and this is called a barycenter, as it's in the center, as that's the orbital plane the 2 stars actually rotate around, and so on. So you can create new star systems all you like, and it'll create plausible planetary profiles. So let's go into one of these HD31. Let's say I would like something a little bit more. I would like to name it. Well, let's name this My Star. If I name it My Star, it'll automatically update all the other names in the system to reflect that. And this is a yellow sun-like star, a good candidate. So how would we say this is a good system? I wish to use it, but I wish to doll it up a bit. I perhaps wish to put a belt out here. So let's put a belt. I just right-hand mouse clicked. I put a belt out here. There we go. I can decide how big I want this belt to be. Let's have it between these two major planets. You can actually set its density and make it this is more for navigation density. So if you're trying to stick a spaceship through it, is it like the ones in Star Wars where they're dodging asteroids, or is it like the asteroid belt we have where you can sail through it pretty easily without any problems? So you can set the density and stuff like that. And this is a very simple simple setup way you can play with the eccentricity of it and various other factors. So what you really want to do here is just play around. You can't do any harm. The star system it gives you initially is plausible with what we know about star systems. However, you can add and play around and mess around with this all you like and create stuff that you need for your narrative. So say I need for my narrative, I really would like a human habitable planet in here, or at least alien habitable planet within the system. Well, what's the easiest way to create one of those? So I'll hit done. I've created this nice ring. What I'll do is what you can do, there are various controls up here, which you'll notice. You've got toggle names, which will obviously what that does, that's on by default. And you have show zones. Show zones is quite interesting because it shows you all the major zones you have for planets. You have a CO line or way out. Here, this is the point where carbon monoxide freezes. This is the point where CO2 freezes, and so and so and so. And frost line is where water freezes. So this is traditionally, if you create a large planet out here, in the frost line, it's going to be an ice giant. If you create one between the frost line and the inside the here, it's probably more likely to be that's outside the frost line. Inside the frost line, it's more likely to be a gas giant if it's big enough. But that's just a terrestrial planet. This is a gas giant. So gas giants are in red. Terrestrial planets are in orangey color, and obviously ice giants are in this icy blue color. So as you see, I'm easily creating extra planets just by right-hand mouse clicking and saying added planet here. This is context sensitive. If I zoom into, say, this gas giant, and I right-hand click here, it'll add a moon rather than a planet, obviously orbiting around here. And that's exactly the same way I created a belt. I can actually create a ring here. So rings I see as just belts around planets, and moons are just planets around other planets. So this is the way you can create rings, multiple ring systems, if you want to be extra fancy, and you can create more complex ring systems and try and simulate Saturn or something like that if you wanted to. You can have great fun just playing around with ring systems and stuff like that. So now you know how to add planets. Let's try and do what we wanted to do before and try and get an Earth-like planet. So I'll zoom out. As I say, you can zoom out using this, or you can actually use the back on your browser button or your mouse button, and that'll take you back up the hierarchy of stars that you've done to take you back here. And I've switched on zones. As you say, in here, you've got a frost line. Within that, you have a habitable zone. Most G-type stars, which are sun-like stars, have habitable zones. You're constantly battling between the heat of the star and the radiation it gives out. G-type stars are fairly low radiation output, but if you start playing around with black holes or even the red, the small red stars, they tend to be very unstable and have very high radiation. So this orange and red effectively show the radiation zones where it's deadly if you get this close to the star, and dangerous. Life is probably unlikely to form in this. And if you go and look at a lot of red dwarfs, you'll find that the habitable zone, the area which is warm enough to the planet for life, tends to be in the radiation zone, getting heavily irradiated. So pick your star carefully if you want to be able to create a stable world. We've actually already got a planet within the habitable zone here, so let's just edit this one and make it actually habitable. So we'll click on it and let's have a look. It's a desert planet because it's running a bit hot at 89 degrees C. If you put your mouse over it, it can tell you where all that temperature comes from. There's a very high greenhouse gas on this planet, which is adding 72 degrees because the atmosphere here is high CO2. It's high CO2, high nitrogen, and what's the surface pressure? What's the surface pressure? Surface gravity. The 2.5 bar. So it's quite high pressure atmosphere, which is why it's so hot. So let's just go down the typical stats you'll get for every single body that's created. So when you randomly create a system in here, you can it calculates all this information from it. There's some physical parameters, as I say, how big it is. It's got a surface gravity. This is a good kind of Earth candidate. It's just a bit hot because it's got a horrible atmosphere, which is too dense. It's still got a habitability score of 33.6. I'll show you how all that. And what you've got here are the orbital zones and delta V budgets. So this tells you if you're putting something in orbit around here, a low orbit is regarded as 2,000 kilometers out. The mid-orbit is 2,000 to 50,000. So these various orbital zones that we come to know. You'll hear about it: LEO, low Earth orbit; HEO, high Earth orbit. So these are how they're calculated from the physical parameters of the planet. And then you've got delta V budgets. So this is what does it cost in fuel and energy to take off from the surface of planet to low orbit, or if you want to get to low orbit to the surface using propulsion, or if you want to use aerobraking, because this has a really thick atmosphere. Actually, just if you've got a ship that can do aerobraking, that means it's got the appropriate shielding and heat shielding, then you can take advantage of the aerobraking and it'll really reduce the ability to land on a planet. So that's where we get to ships. That's a long way off, but it's just to show you. Further down, we have a picture of the planet, and under everywhere you have quick notes. This is where, as a GM, you can type quick notes. GM quick notes are preserved in here. Nobody will ever see them apart from you. They're just written on here. You've also got another description box over on the left here. This here is designed for you to type in your information about the planet. So what you can do is add a bunch of information here, or what I've done is a function here where you can expand that with AI. I'll show you that feature working later. So let's make this habitable. I'm going to hit here and hit edit. And what we're having to go here is we know it's our main problem here is we have. So this is the basics tab. This is the Earth masses. It's almost 2 Earth masses, so we're going to have some quite high gravity. We've got the density and the radius of it. So it's a rock planet. It's not particularly dense. We can probably tune up its radius a little or turn it down to make it more rock-like. And this here actually is, if you go, it's a terrestrial planet, if you go all the way down, you'll turn it, and you go above a certain size, you can turn it from an Earth-like planet into a gas giant. So you'll see it changes from red to a gas giant, and then there's an ice giant, and then it'll become terrestrial and things like that. So we'll just drop these two. You'll notice that these sliders are all logarithmic. So you've got, at the bottom, you've got some fine control, but at the top it can go to thousands without much anything. So this is roughly Earth-sized. We'll keep it at that. We probably want to decrease the size a bit to make it more rock-like. There we go. There we go. So a standard Earth-like planet. And we have, so it's one Earth mass. This information at the bottom always updates. It's 1.2 G. Yeah, it was just more to show you it here. You can change the length of day, things like that, and axial tilt. So let's give it a a 30-hour day or so, a 30-hour day, so it does rotate. So we go to the orbits. This shows the orbit. So this here is representing the red, orange, and green. Here is the same here. And you can see the frost line, the CO line. So just sliding this allows you to slide it out. And you'll see down at the bottom here, the temperature. As you get further away from the sun, the temperature will go down, your orbital period will go up. As you get closer to the sun, it'll get even closer. And then you'll start seeing things like, temperature going really high, and then you'll start seeing perhaps radiation issues kicking in. But this is a very relaxed sun, so it's not going to have anything. So we'll pop it back and sweet into the middle of the Goldilocks zone. And you can, as I say, you can play around with things like eccentricity, which, if I zoom out a bit, you'll be able to see the eccentricity. So you can do stupid things like this. One thing I've got to point out is you can animate these. So I can hit play, and whatever you've got selected will stay in the center of frame, and then it'll show you how the orbital patterns will work. I can zoom, as I say, you can zoom out to get the overall system, so you can actually see the entire star system operating. Don't recommend you leave this on, but obviously you can change it to real time, to various other speeds, so you can go crazy with lots of things spinning. And I guess while I'm up here, I'll point out these other features. You've got a Toy Town view. Toy Town view is, when you actually look at a star map, it's all very spread out. But what a Toy Town view does is put a kind of a fake view on it, where you can start seeing all the moon systems in these planets. So it kind of gives a Toy Town view of your system. And again, it will animate. You've got some counter-rotating retrograde moons going on here, so they're probably captured bodies, because most things always go the same way in the solar system. So, and as you say, this all works, and there's no scale on here, because scale's meaningless in Toy Town view. If you want to scale back, you go all the way back here, and you'll know you're fine, because then the scale will appear at the bottom. Right, where has the scale gone? I'm sure it'll come back. There's, under this show zones, there's a bit of information about all of these zones here, and how you'd use them in game, and what they mean. The last thing I want to show you on here is just the L points. I click this and this shows you the Lagrange points. There are some gravitationally stable Lagrange points, which are the L4 and L5. Which are either side of a body. You put something in those and they'll generally stay. We've got a load of junk hanging around in L4 and L5 points. The other L1, 2, and 3 points they're the saddles. They're actually areas of space where it's hard to maintain a stable orbit. So that's why these are green and the others are not there. If you want to know about Lagrange points, well, there's your button to press it. And again, they're explained a bit on this side here, where it explains what they are. Clicking on anything on this map will get rid of this. Description. Clicking on any new object will then remove it and get back. And that's a crazy star system, another crazy moon system there. So let's get back. Got myself distracted. Let's get back to the Earth-like planet, which we had over here. Let's get rid of that stupid eccentric orbit. And give it a nice round one. And because it's easier to work on. There's some advanced orbital elements. The reason these are advanced is because they have no show on the map. I very consciously kept this to a 2D view of the world, and these are actually the 3D. This is the inclination, how far it is off the plane of the rest of the solar system and stuff. Unless you're in there for data completeness, you probably don't need that information. But as we say, this is for playing around eccentricity. Again, just play with these things. That's the best way of learning. Temperature. So, as we said, we have a 9 degrees surface temperature on here, but we have a total surface temperature of 81 degrees. Because of the greenhouse effect, it's adding 72 Kelvin to it, and tidal heating is what you get if you've got a fast-moving star in an eccentric orbit near a gas giant or something. You'll get some tidal heating. The other thing is obviously the reflectivity, which is albedo of your planet. That's how shiny it is. So how much of the sunlight's reflected and how much of it's absorbed by the planet. So we know the main reason this planet's too hot is because of the crazy atmosphere. So we can edit the atmosphere. So as we go to the atmosphere, we can look on here, and these are typical atmosphere mixes that exist or we expect to exist somewhere in the galaxy. I'm not taking it down to individual levels of components, but each of these will have various different parameters which the software uses to do it. So we want this Earth-like. So let's give it an Earth-like atmosphere, nitrogen, oxygen. It'll give it the Earth mix down here. We've got it. We can change the pressure, the surface pressure. As I say, as we play around with this, you'll see things like the surface temperature changing down at the bottom there. You'll also see the surface radiation changing, since it is the atmosphere that protects radiation. So we want to protect ourselves from radiation, so negligible radiation. And getting it there, we've got, let's take it up to about 1 bar. And what you see is these tags flip in and out as it becomes human habitable. And alien habitable, it's saying this is alien habitable now. And if we go too far off here, it'll change the different priorities. So we have a standard atmosphere. If we go too low, it'll disappear. It's got a thin atmosphere, and go above, it's a thick atmosphere. So these tags are designed for you to understand how it is. They're also fed into the AI generation if you actually want to get a description of your planet. So, as I say, you can play around. Here's the magnetosphere. This is to guide you. So magnetosphere is actually what stops a planet losing its atmosphere. It doesn't really matter for this because you've created this planet. It doesn't matter where it is. But these are the typical ranges for magnetospheres for various planets: gas giants, terrestrial planets, and ice giants. So yeah, just put it somewhere. Liquid. This is there anything on the surface? There are several. What shows up here depends on your planet and your temperature of your planet. There are plenty of liquids, but what happens is it only shows what's going to be liquid at this temperature of 36 degrees and this pressure. So at the moment, water and sulfuric acid are nice and stable. So that's your choice of oceans, and obviously if we want to make this human habitable, we should probably add some water, and we probably want to up the coverage to say about 70% or something. Now we see we've kind of got this looks probably a bit warm because we've played around the atmosphere. There's many ways we can play around with the temperature. We can play with the albedo, which will, as you say, reduce the temperature down. And you'll see it's gone blue. Because if you look at the top here, you'll see it's Earth-like now. If we change the albedo down a bit, we can make it human habitable, in which case it's blue. And it doesn't contain a biosphere yet because we haven't put one on. There's a chance related to time and of our biosphere. So we can do that and say it's now a human habitable planet, but it hasn't got any life on it because we've never hit bio, which is the biosphere. This is the biosphere. This is where it works out a habitability score. So if you get a habitability score of 95%, it's Earth-like. It's human habitable, so if we tweak some of the other parameters down, let's say we've kind of got a simple scoring mechanism here that basically requires liquid solvent on the surface, decent pressures, decent temperatures. This is all close enough to Earth. And what we can do is hit has an evolved biosphere on here, and we can sit there and say whether it's got simple life, complex life, or intelligent life. We can say what sort of life it is, it's water, carbon, and whether it exists by various other bits and pieces. And we can say we have 30% coverage of fungal, microbial, flora, and fauna, we can say. So This here is now a fully populated planet full of life. And we can just hit the last tab here is all the tags which are common tags you can put in, or you can add your own custom tags. This tag system doesn't do a lot at the moment, but it's a plan for building off later on, and you can use this tag system for what you like. But there are variables. So we can say this is a mineral-rich planet with rare metals and is geologically active. There we go. And what we can do is have that information in there, and we can hit done. So we've got an Earth-like planet ready to roll. As you see, we now have a biosphere tab in here. We have our habitability score a lot higher. We have all of our atmosphere and our hydrosphere listed. And it's a bit easier to, it's, as you say, it's harder to aerobrake land now. It's requiring about twice the fuel because the atmosphere is half as thick as it was. So as I say, all of these are physical parameters based on it. So, what we can do is we can expand planet description with AI. I've done this it's a quick fun toy. I can show you how this is set up. You can set it up and call it like a tourist brochure. Let's call it a tourist brochure. We just want to have 250 words. We can say it uses the tags being sent to it. You can put in notes up here. So we can say great zoos. We can go down here and say, oh, it's a corporate enclave. It's a planetary democracy, which is often fragile. And you can click on various other bits. Or we can say it's a religious site or a pilgrimage site. And then we can just hit generate. This will flash away for a bit, and depending on what you set up, it'll just use any one of the it'll just use any AI, and I'll show you how I set up this. Here we go. Welcome, adventurer. Escape to My Stars Sea, because I am I didn't do it. And it'll produce a tourist voucher for this. Obviously, you can view, edit the last prompt. It's got all of the information about the planet being handed to it, so it's trying to build a physical description based on the tags you give it and the other bits and pieces. And you can view and edit the prompt. This is the prompt that's actually sent to the AI. So all of these keywords are being sent to it, all the planetary parameters are being sent to it, and information about the local star, and also all the stuff we've ticked. This is the information that's actually sent to the AI where you're asking for it. So I can just hit Save Changes, and I can hit Accept. And now this here becomes my description. Obviously, you can edit this all you like and manually play around with it. If you don't want to use the AI stuff, that's fine. I can understand some people do. One thing we have noticed here is our image is pretty rubbish as a desert planet. We should probably, as our final thing, and the edit it, is we pick a proper looking sub-Earth, super Earth. It's not a super Earth. It's just Earth-like. Oh, we said it's so say Earth-like, and what it'll do is that's just the image to update. So we've got a different image down here. So we can hit done. We have now set up our solar system. We can say give this a moon by adding I added a planet. I wasn't close enough. That was an example of me setting up a planet, but I wasn't close enough. It looks at what it's called the gravitational sphere of influence. So you got to get quite close, and then I can add a moon. There we go. And this one that I didn't want, obviously I can I think it was this X one. So if we go to the terrestrial planets, I think it was X was this one, the other side. We can go to that, just edit it and delete it. That's fine. If you delete something, obviously it deletes all the stars. All the moons associated with it, anything that's around it. So be careful when you go deleting. So when I'm editing and playing around with the star system, I tend to keep the show zones on because it allows you to more intelligently add planets and play around with them. That is pretty much how solar system creation works. So we can go back to the star map. Important note, when you go back to the star map is the point it actually saves. Up until there, if you refresh this, it won't save anything. But now it's saved. And perhaps what we want to do here is, say, set up a jump route. So I can do start a link, and I can do another link here to complete a link, and it'll just put this in here. It says 3 light years. This is just arbitrary. You can just say that's 10 light years between those two. And you can start setting up jump routes and stuff like this. And obviously that's a good way of so that'll be a lot longer. Say they call that 20 light years. I kept this arbitrary rather than trying to get too clever because you have your own things. If I want to delete one of these systems, I just hit delete system. Simple as that. So be careful. If I hit delete system on here, all my hard work will be deleted as well. But let's get rid of this just because it's cluttering things up. There we go. There's a hamburger menu up here. Let me just quickly go through this. What we have here is this allows you to download your star map. If I hit download star map, I will download the star map file here. This is just a text file. If you open it up, here we go. It's yeah, actually you can't see that. If you open it up, it is just a text file, so you can have you can hand edit it. You can even throw it into an LLM and ask it to edit it for you. You got clear star map, which will take you back to the beginning again, and you got the global settings. So that's stuff you set up at the beginning, which was the the name of the star map and the light year distance and stuff like that. It's all you can reset those and change them as you do it. These are the LLM settings. Here, I just say go to OpenRouter, set yourself up an account. It's free. This I've just used this because it's cheap and free. But what you can do is these are all the LLMs available here, and a lot of them are free. So you can just go and say take the Neutron Nano 31 free. Test it. Always good idea to test it. Successful. And that means that we can use that. So for no outlay, you can use this to a limited degree. Just go to OpenRouter, set yourself up an account, get an API key, put it in this box. That will then populate this list, and you can just choose. All the free ones are at the top. I was just playing around with one. I have no desire to pay money to X, so I'll just leave it here. And you can save. So that's where you set up your settings to actually get the AIs working. And there's a much more fun way you can do it as well. So what you've seen here is I've set up star systems, I've edited stars, and what we'll move on to now is constructs. This is editing fuel and drives. This we'll come back to later. So let's go back into our star system, where we know we've got real things, and let's go and put something like this is perhaps a war-contested zone. Let's go and put an orbital defense platform in here, perhaps, near my star to protect the star. So I'm going to go right, and I'm going to add a construct. The difference between planets and constructs is constructs are items that can be moved around. They can be natural objects. So if you create a construct, we have natural objects. This is where you can put in an asteroid. A Type N asteroid if you wanted to, or you can go back. So this is just a little hierarchy of ideas. These are some ships from Aliens. So if you want to put in the Nostromo, an industrial ship, or military, you want to put in the Sulaco or the dropship, they're all in here. Now these are just placeholders. These are just good starting ships. So let's say put the Sulaco in here. Oh no, we were going to be doing a defense platform. So hard science fiction, infrastructure, defense platform. Here we go. We'll create one of these. A construct is a construct. Anything can be edited upon it. So a defense platform can become an interplanetary shuttle. All you have to do is change the data associated with it. These are just, every one of these constructs is just an initial set to get you started. So if you wanted to play around with various other bits and pieces, like put jump gates, jump points on here, things like that. They're all here. I've just kind of given stuff from Aliens, stuff from The Expanse. So if you wanted to play around with the Doniger or the Rossi or the Canterbury and stuff, they're all in here, and they're all reasonable facsimiles of the stuff there. And the Razorback, if you want to do, let's put the Razorback in. It is a fun ship to fly. It pulls 30G. It's nuts. As you see, exactly the same as planets. You have a whole bunch of information on the right-hand side here. Here we have a fuel mass. We haven't fueled it. We have a dry mass of 15 tons. This thing is not fueled up yet, and it's got a And so therefore it's got a 271 g maximum acceleration because basically you've got no fuel in it. This is insane. It's a racing ship. That's going to kill you. so don't. So don't do it. So what we can do is we can. How do these work? So we've got a defense platform and a spaceship. So let's just have a look. So edit. What we have here, if you go on edit, is much like planets and stars. You can edit stars as well. I won't go into that. But you can have a defense platform here. The icon, as you see, is this white square. You can choose between these things and set a color and things like that. Then you've got its mass. It's a 30,000-ton ship. Sorry, this thing here. It doesn't have aerobraking or landing gear. It's got no thermal protection because this thing is not really designed to come near a planet. So the orbit is pretty similar. You can change its orbital position to where you start here. And again, you can play around with eccentricity and play around with eccentricity of orbits and stuff like that. So it's all the same thing. And this here shows you where it is. So just by dragging this along, you can move it further away and closer to. But let's say we wanted it near the green planet because it's what we're trying to defend. And this allows you to play around and move it into different places. You'll see the zone changing on the right. Engines. This thing has 2 methalox. Okay, it isn't going to go far with 2 of those. These, as you say, are high thrust, low ISP engines. These are just going to be maneuvering jets and something like this, and I probably wouldn't use methalox. And obviously, for every engine, you need fuel. And here there's 200 cubic meters. So these are just going to be more keeping on station than anything else. You've got cargo capacity here, where you can put cargo in and put a description of cargo in. You can put a crew in here, a max crew. And you can put consumables if you're running the sort of game where you're wanting to keep a track of food and things like that. You've got power. This doesn't particularly do anything. This is more for completeness. And again, modules, you can just add and remove arbitrary things here. So this is where you can define your spaceship or your defense platform and stuff like that. And again, like everything else, as we can expand this with AI. I particularly like the ship spotters blog. You get an over-enthusiastic ship spotter. Just say that this particular one is a utilitarian, gothic. It's got spire-like orientation. Let's give it its aging. These are just, as I say, if you want, you can put extra information up here if you wanted. This is just to inspire you, to give you a few ideas about this, and then you can hit generate. And again, what we'll do is this is from a different generation engine, so I'm not sure how it'll come out. Here we go. Spotter's blog. We've got 500 words. From an obsessive nebula nerd, obsessive ship spotter, and collector of external details. So the whole idea of this is just some flavor text and some fun bits and pieces, where it's to inspire you as a game master or anyone else to just do it. So I would absolutely not, for the special stuff, use your own imagination. But when you're just wanting to put some cool bits and pieces in there to of interest to players, just do this, and then again accept. And we have this brutalist deep space relic of brutalist grandeur, where it's got lots of things. It's even giving you some GM hooks on this one. Who the hell knows what you can do? So ships are very much done. This thing is not really a mobile ship, unlike the Razorback. So let's go to the Razorback. And what we'll do for the Razorback is, from its orbital position away out here, for a start, it's got 1 crew in here. Let's give him some food. We've got 20 days of food. This isn't a cargo ship. What modules does it have? It has a high G tank, crash couches. That's good because this is a high G ship. As you see, as soon as we start putting fuel in this thing, you'll notice our maximum acceleration will go down. There's lots of mouse overs here, which will tell you further information about any of these bits and pieces. So use those tool trips. And I can just turn up the fuel in this. As I say, as soon as I actually fill it up full, we can only pull a maximum of 20G. Still ridiculous, but pretty good. That's because these contain these unfortunately named Epstein fusion drives from the Expanse. So the Razorback is a racing ship designed to pull 20 to 30G. When you put the figures in here, that's exactly what it pulled, 20 to 30G most of the time. So we can say it's orbiting my stars, which is the name of the sun, at 1.25 AU. So what we can do is we've done editing this. You can also change where it is exactly the same way planets, and you hit done. What we can do is, let's say we want to fly to my star's C, and we want to land on that planet. So what we want to do is plan a transit. So we plan transit. And what we want to do is set a destination. Our destination here is my star C, because there. And what it's done is it's given you a few options. Some very high efficiency. So this will only use half a ton of fuel and get you there in 148 days. This one will still only use half a ton of fuel and get you there in 92 days. What you'll notice here, let's just describe this. This is where you're aiming for, the low orbit, or the moon of this place. So that's my target. My current position is deep space, effectively. I'm going to be heading in here. It has to come in this way because that's the way the planet is rotating, if you'll see here. Oh, sorry, the plane doesn't work in planning. But what happens is you've got all the fuel estimates and things like that. It's partially aero braking, which is probably what this peak at the end is here, as it's using the atmosphere of the planet to brake. What you've got here is a timeline profile, so I can drag this along and it'll show you on the map how everything goes. So what we're doing is we're doing an intercept to my star C over a period of 92 days. And it passes through this danger zone. So what's that? Well, that you'll find out if you switch on the zones, is we're passing through a relatively high radiation zone. If we were to do something like, let's close the planner, let's say if we were to put in a particularly dense belt here. So let's make this a really hazardous belt and make it a bit larger. Done. Now let's get back to the Razorback. Again, you can click the constructs and get to the Razorback up here. It's the fast way to get to it, and we can plan our transit. And we'll again go to that Earth-like planet. Now what you see is I have belts problems as well as radiation problems. I have to travel through the belt twice. So the point of this here is to give GM tips as to when you're going to want dice rolls from your players. You're probably going to want a dice roll. It's a dense debris field which you have to pass through. Then perhaps you need to make them get them to roll some body rolls or something like that, or ensure they get some radiation because they're getting close to the star as they go through the radiation belt. And then, as you said, and then they have to go through the belt again, which will probably be another navigation check and stuff like that. And then right at the end, there's a bit of aero braking as well. So you'll see this is taking days. But what we probably want to do is direct burn it. If you're in a ship this powerful and it only takes 20 tons of fuel, rather than taking 90 days to do this, you can just direct burn it. Obviously, with all things, you can do a departure delay and wait till your destination is just closer. So if I waited 400, well, if I waited a number of days, as I say, it's continually recalculating all the routes. I can effectively make the journey shorter, which is how we get from Earth to Mars only a few months a year, a few months every few years is for that. You'll notice you occasionally get some crazy some crazy plans given for you as it tries to use various resolvers to try and do it. But say we didn't want to, as I say, there we go. Now, this is taking 6 days and using 19 tons of fuel. Let's turn the burn profile. We can burn the profile even more, and therefore we're reducing it. We're increasing the fuel, but taking less time. And you'll see the green part of this is burning profile, is burning. The red is braking. It corresponds to this here. So you can do this, and this will change your actual fuel and the way you need to go. And obviously, it's targeting where it's going to be at that point in the future. So if you go slower, it's got to be further around the orbit, and if you get closer, it's a bit going on. You can thread these together. You can add another leg and another leg, and you keep adding legs of a journey on until you do it. And you'll see our burn profile here. If we wanted to burn harder, we're only doing a 1G acceleration. We can perhaps do 2G acceleration. Now we're getting into some high G zone. Gets a bit dangerous. We can turn it up to say, because the ship can do 10G, let's do it. And obviously now we're getting extremely hazardous. And what this is showing here, it'll say extreme G, 12.9G, because you're accelerating here. Then you're in your coast phase. Then you're in your dense debris field, and then you're passing through here, etc., etc., etc. So you've got all of this information on here to kind of help you as a GM determine when your players are going to roll dice and things like that. And then you can just hit execute journey, and it'll just do a nice little transit pattern up here with all the stars moving into place, and suddenly we are now at this here. And what we can do is say, this is where he's saying, is landing and takeoff analysis possible? Yeah, I can land for no fuel because it's a nice thick atmosphere and this ship's very, very efficient. I'll take only 0.2 tons of fuel to take off because this is effectively a magic space drive. If I can show you a more realistic ship, or I can just land and that'll put us on the planet, and then you can take off and stuff like that. So that drops you into low Earth orbit and backwards and forwards. So that effectively shows you how you can mess around with ships, your constructs. You can edit it, you can add more fuels, you can mess around with engines. I can remove this engine and add a different sort of engines. And these are these are all theoretically here. Down the bottom of this list, it gets more and more fantasy, like the fusion drive. But all of these ones are authentic. We can actually do something. So, but what happens? That's pretty much most of what this does. So let's zoom out and let me just show you a couple other features quickly. This here is the edit fuel and drives. Those drive definitions, those fuel definitions which you saw under here, and the density of the fuel here and the engine definitions, these are, you need an ISP and a thrust. These are physically accurate engines. If we get back to something like simple basic engine like a Methalox drive, that's the thing that's on the Starship. It's a chemical, it needs Methalox, this is the rough thrust and this is the ISP. Thrust is great for getting you off a planet, accelerating you through atmosphere and getting into orbit. ISP is what you need once you're in space and you need to get between places efficiently. So if you kind of built something like Starship in this, or any of the big dumb boosters that are being developed at the moment, then you'll find that you probably have to add about 30 of these engines. Then you can get into low Earth orbit for about 6,000 tons of fuel. But then you won't be able to get to Mars or Venus because you need to drop a load of mass and have more efficient engines for doing that sort of drive. You can do it. I mean, you can simulate. That's why the entire Starship doesn't make it out, and it's multi-stage. I've deliberately not done multi-stage in this. This is designed for science fiction games. It's assuming we're beyond throwing away half the rocket, and we're actually using reusable rockets. So, that, again, if you're wanting that level of detail, crack out Kerbal Space Program. This is more meant for quick, dirty fun in a role-playing game. You save the changes. So you've seen everything in here. If, say, I wanted to go to this planet here, and I wanted to regenerate it because I don't like it, this is what these buttons are for. I can just hit generate system, and I can carry on generate systems more or less indefinitely, and you can carry on clicking this as fast as you want until you come across a planet or you like. Well, perhaps you want you'd actually like to generate an empty system. That'll give you just a blank starting plate, and this is a type star. You can also pick which star. So you want to type O, I can generate, and this is these are incredibly stupidly high radiation zones. Again, if we look and show the zones in a star like this, it's radiation, and so it is way out here, all the way. It's hazardous all the way out until where Jupiter, beyond Jupiter, and stuff like that would be where we are. And the habitable zone is slap bang in the middle of this high radiation. You are not going to be getting life around a Type O star. But we can keep on generating systems with Type O. We can actually sit there and Type A as well. And again, you can edit stars. I've got sliders, so you can actually change the effective temperature by changing this, and this will change the typing. And as you say, if I'm at a Type M, it tend to suffer from the heat there, and then as we go out, we get radiation zones and habitable zones all playing around with each other, interacting, and you can set the radiation level of the star and your solar masses and stuff like this. We've only really discussed stars. There are things that aren't stars. You'll notice that there are things that aren't stars, and that's the ones down at the bottom here. WD is white dwarf. White dwarfs, red giants, neutron stars, magnetars, black holes, active black holes. These are all effectively kind of stellar remnants. They're stars on their way out or have passed. So you can't. You can create these, but when you hand edit them, you can't hand edit to create these because this system is designed for standard stars, your main sequence stars, and what we have here is none main sequence stars. So if we start with a red giant here, we can generate a red giant system here, which is a huge. It'll generate a huge red giant star with a few planets and random stuff around it as well. And if you wanted to, yeah, absolutely, you could build yourself a black hole, generate a system around a black hole. You'll tend to find around black holes there's quite a lot of radiation, and because they don't give out a lot of heat, there's not really a habitable zone. But this is the Roche limit is what's important here. That's basically when you're going to start getting shredded. So that's the important one as far as there. And as you say, there are no planets on this. These generate physically plausible planets. So if I generate a system, if I keep on going, there may be a chance we'll get one with a planet. It's not that they can't appear, it's just they're very rare. We don't know whether this is true, but because we don't really have close observations of black holes. But all of this works on contemporary physics and what we understand. So this is how you get your neutron stars, your magnetars, your black hole binaries. And as I say, we've done a black hole binary here to the star map, and now this will be updated. Which one was it? Oh. There's a bug. I'll get that fixed by the time you look at it. Right, so once you're in here and you've played around with all your star systems, you can go back in. Everything's still in here. Our constructs are still in here, our dephased platform. The Razorback, which we left orbiting this planet's there. Everything kind of pulls together. But what we also have in here is this hamburger menu here. So here is downloading a system. This is just this one star system. So if you wanted to clone a star system, put it elsewhere, you wanted to save off a star system and reuse it later on, this is where you can just download a system or upload a system. So this is just one star and its planets and everything around its planets are saved. There's also this open projector view. Open projector view opens a second window, which you can't see on here, but what it does is it's designed for the play window. It's designed to go on the big screen or the one you show across your virtual tabletop. And what it does is it shows exactly the same as the view as I'm seeing here, but without any of the UI clutter around it, so they can do it. You can do also CRT mode, so it looks like a dodgy green screen they're looking at too. So just for a bit of atmosphere. Generating reports. If we generate reports, so the purpose of these are reports you can give your players. of the star system. So we can get full intel, and you get a player which are redacted. So you'll see on all of these things, you'll see you can hide planets, you can hide um, you can you can hide constructs if they don't know where they are just by pressing this button. This means it won't show up to the players. Um, and indeed, it won't show up on the projection view either. So if they're looking at the projection view, you can hide things on your map and they won't show up on their map. And that'll allow you to put it back. You can also just hide the description. So effectively, if the purpose of that is if they come to this planet, this Earth-like planet, you don't have to feed them the description. You can hide the description. They'll know they can get all the physical characteristics. So let's say this. I've done this. The Razorback. I've got this, and I've hidden the information. If I then do a generate report, you get the player one, so that hides the spoilers, it hides the GM notes, it hides the construct and hidden constructs, so it hides things. This, if you want a GM report, it shows everything. So I'll show you, and you can choose whether to not to include the constructs, just in case you want to give them just you may just want to give them the raw science data of a system. And you've got some various visual themes too. So I can hit Generate Report, it'll open a new tab, and what I've got here is I can print it and save it, and this is something you can hand to a player, and this is just the full information. So it's got the GM notes sections in here. We've never used any on this one, but this is the GM view. So it's seeing everything, including this description of the stars, but we've said we'd hide that description from players. So if we create a generator report for the players, we can generate that report. You'll notice as we go down, that description is most definitely missing. They've got very much a case of a report that looks like it's come out of a dodgy teletype printer. They've got the defense platform because we told it to include that and we haven't hidden it. So that's why they still see that. And so all that information, all those descriptions, and also you'll notice on here there's no sections for GM notes. So you can create a copy for yourself, create a copy for your players, so they've got a cool reference guide to use whilst they're doing it. That's pretty much it about. So I would tell you, this is the current version where we are. So I'm showing you version 1.3 at the moment. I would urge you, if you want to get involved, learn a bit more about it, understand where we're going, come and join us on Discord. You click on Discord, we've got a community here where you can come and chat to me, give us your errors and tell us where things are not working, tell us where, give us bug reports and I'll help you out, or queries, and hopefully we'll build a user community here that'll be a bit more useful. Any questions, just pop on there and do it. Link in the description and do it. I'm not going to say follow and subscribe because that's what every YouTuber says and I'm not a YouTuber. This is just an amateur video to show you how it works. So hopefully that all makes sense. One last thing, the presets is the last thing I'd like to show you. So if you go into here, I can sit here and if I create a system and start editing a system, you'll notice that that line disappears. That was because if you hit anything on that line, it regenerates the system. And what I didn't want to do is allow you to regenerate a system you're actively editing. You'd wreck it a bit much. But what you can do is I can click in here and say, show regenerate controls and get those back. And once we're in these, that'll allow us to overwrite the system something new or pick a selected one. So we can say, pick our solar system. Here we go. And so now we have our solar system in here. As you say, it all plays ball. We can actually run around here. And on Earth, we've got a couple of constructs, a heavy lifter, we've got the International Space Station, we've got the Lunar Gateway. We're assuming this is 2030. We've got our big Ascension heavy lifter. It's got these 30 engines. It can take off. We can get it to take off. There we go. We can try and plan a transit, but this thing is, well, we're out of fuel now, but it can't even get to the moon. it needs more fuel. And this is where you'll hit the tyranny of the rocket equation. Oh, we only need a little more fuel, but unfortunately, the more fuel you add, the heavier the ship, the more fuel you need, the heavier the ship, the more fuel you need, the heavier the ship. And you'll get caught up in the tyranny of the rocket equation, which is kind of fun. Um, just because like the ship doesn't have the engine capability to do a direct burn. So this, the purpose of this is it's trying to give you the information you need if you're wanting to try and create something semi-realistic. Is saying, well, if you have this sort of engine with this sort of thing, then it's impossible for it to actually get you there by direct burn. These ships can only follow these highly efficient ones, and even then you need a whole crap ton of fuel. And probably on this particular craft, you probably have to you lose a bunch of mass as well. You'd have to probably, yeah, just try and get it anywhere because these are not efficient engines. So all the credits are down here. As I say, this is totally open source. I've And I, as I say, have absolutely no desire, as I vibe coded this. I don't think I can charge for it, and therefore it's going to be free for everyone. And if you wish to pick up the code, have a go with it, or try continuing to vibe code it yourself, go ahead. Down here, say you have some GM quick notes for the whole star system for you putting your global information in there just for your notes. And the other one you can do is if I clear the star map, which will delete everything we've done, one of your options here is the local neighborhood. So you get a local neighborhood, and this here actually shows you kind of like the couple dozen closest stars to Sol. And in here you have each of these correctly modeled up to the kind of information we know now, including Alpha Centauri, which is a triple star system. You can't deliberately create, if you want to create triple star systems, just grab Alpha Centauri, just go to Alpha Centauri, mess around with say one of the stars, edit it, change the type of star it is, have a good mess around. And then just do save system, download system. Then you can have that system handy to reuse anywhere you want. So if you want a triple star system, I recommend you just grab Proxima Centauri. If you show regenerate controls, one of the options on here is the Alpha Centauri system. So there is a triple star system in there. There's no practical limits. It's just I stopped at binary because binary systems cover 99% of what's out there. And also, once you start getting more than binary, things can get very gravitationally unstable. And I'm trying to create scientifically plausible systems. So triple systems like this are relatively rare as far as we're aware. The interesting thing about Alpha Centauri here, Proxima Centauri, is it's really two double systems. You have a pair of stars. You have a pair of stars you have a pair of stars here, and then zoom. You have a single star there orbiting a pair of stars. So these go around each other relatively speedily. So that's the two Alpha Centauri stars. And then we got Proxima Centauri, which although Proxima Centauri is currently the closest star to us, that will probably change over time. And here is that it's going to rotate around this. So this is actually like two binary systems. So anyway, I'm not here to give you physics lessons, astronomy lessons. Give them to yourself as you go. But I think that's pretty much everything in here. Again, hit us on the join us on the Discord. And good luck with the software. Have fun and let me know what you use it for. I'll be hell of interested. Join the community. Say hi. I'm friendly. So is everyone else. Thanks then. Bye.